Assalamualaikum, how are you guys doing? I hope you guys doing great. And in this video we're gonna create this landing page kind of thing, but our main focus is gonna be this earth and this is study background. So without any further ado, let's get started. Okay, so to create this landing page, we're gonna use THREE.js, and in case if you don't know what THREE.js is, let me give you a short introduction. THREE.js is a JavaScript library which you can use to render 3D object on your browser. And now what you need to do is you have to create a folder anywhere in your computer, and inside of that folder, let's create a file. It's a JavaScript file. Let's create a file called server.js. And now inside of this root directory, create another folder called public, and inside of this public directory we need to create index.html and another file, let's call it style.css, and then let's create our final file, we're gonna call it client.js. It's a JavaScript file, and our all THREE.js code is gonna be inside of this client.js. And now you can open this folder inside your code editor. I am using Visual Studio as my code editor. You can use anything you wish to. So as we can see, I have opened my project directory inside my Visual Studio. And now let's first of all create our server to serve our static files. So to create our server, we're gonna use Node and Express. So if you are using Visual Studio, you can click on this terminal and the new terminal. It will open up a terminal for you. So now let's type npm init and -y to accept the default values. So the next thing we need for our server is Express.js. So let's install the Express.js. So to install the Express.js, type npm install express and hit enter. Okay, so it is done. So the next thing we need to install is our THREE.js. So npm install 3. But the problem is if you install this in this way, it's gonna install the latest version of 3. But the problem with the latest version I have faced that it wasn't working with me. I don't know what's wrong with this. So I'm gonna go with some older version. Maybe it's already fixed. So the problem I was facing, maybe it's already fixed. You can use the latest version. If it doesn't work, you can specify an older version like so to specify the version, you have to type @ and the version number. So in here the version is gonna be 0.1.27.0, and then let's hit enter. So it's gonna install that specific version we have given. So let's check it out if it's installed or not. So here you can see inside of this package.json file, it has installed that specific version we have given. So another thing, if inside of your package.json, if this line is not written, you can type it manually, because if you don't do it, your server is not going to run. So our setup is complete. Now let's create our server. So let's open server.js file, and inside of this server.js file, let's say const express equal require express, and then let's say const app equal express, and then we're gonna need path. Let's say const path equal require path, and then let's say we're gonna set some middleware to serve our static file. So first of all, let's say app.use express.static, and let's say __ dir name, and then let's concatenate this with our public folder, because we're gonna serve this public folder because all our static files is inside our public folder. So, and then let's say app.use /build and / again, and let's say express.static.path.join, and let's say __ dir name, and now let's give the relative path of our THREE.js file. So the relative path is gonna be node modules /3/build. So beside this THREE.js file, we need some few things like orbit control and stacks. So how we're gonna use that, we're gonna discuss this later. But first of all, let's give their relative path. Let's say app.use and let's say jsm/jsm, and then the same way I'm going to let's just copy this line. Now let's replace this build with JSM and let's say 3/example and /JSM. And now let's say app.listen to let's say 4000, and let's say callback function, and inside this callback function let's say console.log, let's say visit is TTP //127.0.0.1 and 0.1 clone 4000. So our server is ready. So as you can see, it's pretty straightforward. You just can copy and paste this code into your project. So now let's move to our index.html file. So if you're using Visual Studio Code, you just can simply type exclamation mark and hit enter. It will give you a simple boilerplate of HTML. And now let's set the title to THREE.js Earth. And now let's link our CSS file. Let's say link clone CSS, and it's going to link our CSS file. And then we have to link our JS file, JavaScript file. Let's say script src and let's say client.js. And then inside of this body we need something that will hold our earth, the art we have created, the art we are going to create, and the background. As you can see, we need something to hold out this art and the background. So let's say I'm going to use canvas. So let's say canvas, and let's give it a class called WebGL. And this is it for our HTML part for now. We're going to come back to HTML later to add some more elements. And now let's move on to our client.js. And inside of this client.js, let's first of all import our necessary things. Let's say import all as 3. Make sure 3 is in total capital. 3 from build, and let's say 3.module.js. To make sure that we have imported it correctly or not, let's console log it to see if we imported it correctly or not. So let's say console log 3 and hit save. And before that, let's run our server. On your terminal, let's type npm start. And now if you click and hold the control and click on this link, it will open your default browser. And you can see a blank window is open. And now if you inspect and go to the console, so you can see that we got an error that cannot use import statement outside a module. So to fix this issue, let's go back to our HTML file and let's give it a type called module. And now let's hit save and let's refresh it. And as you can see, our module is being displayed here. And then let's import orbit control from JSM controls /orbit control .js. Okay, so now let's again console log it to see that if we are imported correctly or not. So as you can see, we have imported it correctly. And now third thing we're going to need is called stats. So stat is basically so you can see this thing on top left corner which is showing that at what FPS your scene is being rendered. So to display this, we're gonna need stats. So let's import it first. Import stats from gsm/library libs, and let's say stats.module.js. And now similarly, let's say console log stats, and let's see if we imported it correctly. Refresh it, and as you can see, we imported it correctly. Now you can delete this console log, we don't need it anymore. So to render any 3D object with Three.js on your browser, you always need three things. The first one is the scene. So scene basically a container for your all 3D objects. So your all 3D objects or models will be contained inside this scene. And the second thing is the camera. So once you have your 3D models inside the scene, and now you need to see them. To see those 3D models, you will need the camera. You can't see anything inside your scene without this camera. So you will need camera to see those 3D objects. And the third major component is renderer. So you can't see your objects until or unless you render them. So to render them, we are going to use the renderer. So if I summarize this, every 3D objects will be contained inside scene, and you will see them through your camera, but you can't see them until or unless you render them. Okay? So now let's create them. So to create them, I'm gonna create some global variable first of all. Let scene, this is the first component, and the second is let camera, and third one was renderer. So this is our three major components we're gonna need for every Three.js project. So now let's create a scene. So to create a scene inside of Three.js, it's really simple. You just have to do is, let's say scene equal new 3, make sure 3 is all uppercase, and 3.scene, scene. Make sure this is uppercase and parenthesis. That's it. Our scene is created. And then our second main thing is the camera. Let's set up the camera first. So to set up a camera, we need few variables, we need few things. Let's understand them one by one. So first of all, we need, let's say const FOV. So FOV is basically field of view. That means that how much you want to see. And remember, this value is always in degree. So let's say 60 means 60 degree. So our view angle is gonna be 60 degree. But if you want something like wide angle lens, you can increase this like to maybe 90 degree to 100 degree or maybe 120 degree. So this is basically field of view, that how much wider or how much narrow you want. So I'm just gonna go with 60, and you can obviously experiment with this. And then the second thing, we need the aspect. We need the aspect of the screen. So to get the correct aspect of any screen, what we are going to do, we are going to, let's say const aspect equal window dot inner height, window dot inner width divided by window dot inner height. Okay, so this will give me the perfect aspect of any screen. And next thing, we need a value called near, let's say 0.1. So you can understand near in this way, that suppose distance between your object and your camera is 0.1 or less than 0.1. So in that case, your object will not be visible. And similarly, we need another value called far, let's say 1000. So if distance between your object and your camera is greater than 1000, your object also will not be visible. If the distance between your camera and your object is less than 0.1, then your object will not be visible. And if the distance between your object and your camera is greater than 1000, it also will not be visible. So you have to keep your object within this range. Okay, you can obviously decrease the near value or increase the far value if you want to, but I'm gonna go with this. And then let's say camera equal new, and again 3 all uppercase dot perspective camera. So we're gonna use perspective camera, and this perspective camera takes few arguments like field of view or FOV. We have already declared it. Let's say FOV, and it takes an aspect. So let's say we have already defined it. So let's say aspect, and near value also defined it, and a far value. So we pass all those variables inside this perspective camera. Okay, and then we have to set the camera's position. So we need to set the camera's position is because initially they basically they stay together. That's mean they overlap each other, so you can't see anything. So we have to pull back that camera from our object. So let's say camera dot position dot z equal, let's say 2, and then we have to add this camera to our scene. So let's say scene dot add camera. Okay, so as we are done with our camera, now let's move on to our renderer. So to create our renderer, let's say renderer equal new 3.webgl renderer. So we are going to use WebGL renderer to render our objects. So inside of this renderer, we have to say to renderer that where we are going to render our 3D objects. So if you remember, we have created a canvas tag to put all our 3D object inside this canvas, right? So now let's grab this. To grab this, let's say const canvas equal document dot query selector, and we're going to select the WebGL dot WebGL. You remember the class we have set for canvas, that's one. And now let's tell this to our renderer that we want to render our objects inside the canvas element. So let's say canvas clone canvas, and then let's say anti-alias is true. So now let's set a size for our renderer. To set a size for renderer, let's say renderer dot set size, and now we want to want that our renderer take entire of this screen, right? So to do that, let's say window dot inner width and window dot inner height. Okay, so it's going to take the entire of our screen. And then let's say renderer dot set pixel ratio, and the pixel ratio is gonna be window dot device pixel ratio. Okay, it's pretty much self-explanatory that that is going to take the exact pixel ratio the screen has, right? So now let's renderer dot auto clear equal false, and renderer dot set color, set clear color. Let's say we are gonna set the black color. So by default the background is gonna be black, so we're gonna use hex code. So if you want to use hex value in THREE.js, you have to put this 0 and x in front of your hex value, and then you can put your hex value, and then let's say 0.0. So now we have to render it. So let's say renderer dot render, and now we want to render the scene and the camera. And now if I hit save and let's go to the browser, and we should see this black screen. So the issue with this, the white margin, we have to remove it, the default browser margin. So remove that margin. Let's go to our style sheet and let's select the universal selector, and let's say margin equals 0, and hit save, and let's see, and it's fixed. Okay, great. We have a scroll bar, but we'll deal with that later. For now, let's focus on our JS. So now we have to create basic structure of the earth. So what's the basic structure of earth? It's simple. It's a sphere, right? It's kind of like a sphere. So we have to creates something that looks something like a sphere. So in Three.js, to create a sphere, we just have to do is, let's say const, let's say earth geometry. So the geometry is gonna be sphere geometry. Sphere geometry. Okay, so sphere geometry takes few arguments. First one is a radius. So let's say radius is 0.6, and second is width segment, that how many segments you want along the width. So let's say 32, and then how many segments you want along the height. Also I'm gonna give it to 32. And then we have to create a material for our earth. So we have created the geometry, and now we have to create a material for our earth. So similarly, there's a const earth material is equal to new 3.mesh form material. So there have a lot of different materials you can use with Three.js. You can see them in Three.js official documentation. I will give the link in my description. You can check them out. But for this video, we are going to use form material, and inside this form material, let's say roughness. Roughness is 1, and metalness is 0. Okay, so our metal is also ready, and now we have to create the actual shape of our earth. So to create an actual shape, we need to create a mesh out of this material and this geometry. So how do you do this? So to create a mesh, let's say const earth mesh and new 3.mesh. And now this mesh takes two arguments. First one, the geometry. So we have already defined the geometry. So geometry is the earth geometry. And second argument it takes is the material. We also define the material. Let's say earth material. Okay. And now we have to do is, we have to add this to our scene. So this is scene.add earth material, earth mesh. And now let's check it out. Can we see something or not? Let's go to our browser and refresh, and we can't see nothing. Why we can't see nothing is because there have no light. We need a light source to see the object. So form material is a material which interact with light. You can see those material without the light. We need a light source to see this mesh. So now let's create a light source. So we are going to use ambient light. So let's say const ambient light is equal to new ambient light. And this ambient light take two parameters. First one is the color of light. Let's say I want white color, so let's say 0x ff. This is the hex code for white color. And the second argument, it takes the intensity of its light. So let's say 0.2, the intensity of light. And now let's add the ambient light to our scene. So let's say scene.add ambient light. So now let's see that we can see something or not. And let's go to the browser and refresh. Well, we can see nothing. Let me see what's wrong with this. Okay, I'm sorry, I did a mistake. You have to put this renderer at the very bottom. Okay, so you have to put this line at the very bottom. Okay, now let's hit save and let's see, refresh, and there you go, guys. We have this sphere on our browser. Okay, so as we got our sphere, now let's add some more light to it. We are gonna use another light that's called point light. So let's create a point light. Const point light is equal to new 3. And I hope you guessed it, point light. So 3. point light, and the color is going to be white, same as ambient light. white, and the intensity is gonna be, let's say, 1. And then we have to do is we have to set a position for this point light. So let's set a position. Let's say point light dot position dot set, sorry, not point light, position dot set, and here we have to pass 3 values. 3 value is, let's say, x, y, and z value. So now let's set the x value to 5 and y to 3 and z to 5, and then again we have to add this to our scene. So scene dot add point light. Now let's hit save and let's see and refresh. We can see our sphere clearly. So as we're done with our sphere, let's add some texture on top of it so that it looks more like earth. So to add some texture, let's come to this earth material. Inside of this earth material, let's say map 3 dot image utils dot load texture, and inside of it we have to give the relative path of that texture file. So in my case, that texture is in inside of this texture folder I have created. So here inside this public directory I have created another texture folder, and inside of this texture folder I have all those texture I'm gonna use in this video. Don't worry, I'll give the project link in my description so you can download it and you can copy paste this folder into your project and you can use this. So I'm just gonna use a texture which is within this texture folder. Let's say the name of this texture is let me just copy it. Now let's save and let's see how it's looking. Refresh. Well, we can see nothing. Oh, sorry, I did put a semicolon over here. It's an object, can't put a semicolon. Okay, so we can see something, but it's not looking like earth. I don't know you guys can see it or not. This reflection of this sphere, we can see it, but we are not getting that whole earth, right? We are not getting that whole sphere. So to see the whole sphere, we have to create a function which will run in every frame. So, and in this function we are also going to animate our earth. So let's do this first. Before that let's put this line into a function. Let's say const render equal, I'm gonna use arrow function. So, and let's say put this line inside of this, and now let's create another function called const animate, and similarly I'm going to use arrow function, and inside of this function let's say request animation frame, and you have to pass this animate function inside of this. So basically what this line is doing is looping this animation function again and again. So this function is going to run in every frame. Okay, so now let's take the earth mesh and let's rotate it. Rotation dot y, we are going to rotate this earth in y axis. So let's say y minus equal 0.0015, and this 0.0015 is the rotation value, that how many rotation you want. If you want more rotation, basically if you want more fast rotation, then you can increase this value. If you want more slow rotation, then you can decrease this value. Okay, so now let's call the render function to render everything, and finally at the very bottom let's call our animate function, and let's see what we get. Refresh, and there you go, my friend, we got our earth. But this earth is looking really flat, right? It's not looking like this the original one. Is like kind of, it's got more texture, it's got some bump, but in here this is totally flat, right? So to get this kind of result, we have to add a map that's called bump map. So bump map basically contains the information of how much bump you want on your surface. So you already have this bump map, but if you want, you can create your own bump map on Photoshop. I'm not going to show that in this video because video is going to be too long. But if you guys want, I can create a separate video for this, that how you can create a bump map on Photoshop, or you can search online, you can get a lot of videos, or you can simply use this bump map which I have already created for you guys. I'll give the all link in my description. Go check it out and use it on your project. Okay, to use bump map, let's go to our material again and let's put a comma and let's say bump map then 3.similarly image util / load texture, and we have to give the path of our bump map. So the path is texture / earth bumpmap.jpg, and now let's say a comma, and then let's say bump scale, and let's say bump scale is 0.3. So the bump scale, what is this bump scale is doing is basically increasing or decreasing the bump of your surface. So if you increase this value, your bump will be really high. If you decrease the value, your bump will be down according to this value. So now let's hit save and let's check it out. Refresh. So there you go, my friend, we have applied the bump map on our sphere. Okay, now let's add some camera control that we can move this sphere with our mouse. At this moment we can do this. To do this we need something called orbit control to do this. So let's add a orbit control. Okay, let's add it here. Let's say const controls equal new orbit control, and the orbit control is going to take some parameter. The first parameter this when we're gonna use our mouse, which element I want to rotate. So I want to rotate the camera, right? And then we have to call the renderer DOM element to render this scene in every frame. Okay, and now we have to add this control to our animate function. So inside of this animate function, simply we have to update the controls.update. Okay, now this is save and let's see. So now we can rotate our sphere with our mouse. So with left mouse button, click and hold the left mouse button and you can rotate it. You can zoom in and zoom out with your mouse wheel, and with right mouse button you can just move it around like this. Okay, so this is our orbit control. Okay, so as we're done with our earth, now we have to add some cloud on top of this earth so it will look more realistic. So now let's add some cloud texture. So let's come here and let's say const cloud geometry, and let's say new 3 dot. So here again we are going to take the sphere geometry because we are going to create an sphere, but this sphere is going to be slightly bigger than our earth sphere, right? So let's say again the radius is going to be slightly big, so let's say 63 not 16, sorry, and let's say width segment is 32 and height segment is as well 32. And again we need a material, so let's say const cloud material equal new 3 dot. Again we are going to use fog material, so let's say mesh fog material, and inside of this we need the cloud texture, right? So I already have this cloud texture, so we're going to use this. Let's say again map 3 dot image util dot load texture, and let's give the path is texture slash the name of the file, and let's say hit save. And now we have to create mesh out of this cloud geometry and this cloud material. So let's create a mesh const cloud mesh, and let's say new 3 dot mesh, and now let's pass here cloud geometry and cloud material, and let's say add this to our scene dot add cloud mesh cl, let's say cloud mesh, and let's say hit save, and let's see, refresh. So it's not looking like this original one, right? So the reason is, if you notice that the original one the cloud is transparent, but this one the cloud is not transparent, so we have to make it transparent. Okay, so to make transparent, let's say transparent true, and hit save. Let's refresh, and there you go guys, our cloud is on top of our earth, but the cloud is not rotating, right? Cloud is not rotating, so it's looking weird. So let's rotate it. So we have to go to our animate function, and let's say cloud mesh dot rotation dot y minus equal. So let me clear one thing, that minus mean anti-clockwise, and if you put a plus here, it means clockwise. So we're going to rotate it anti-clockwise on our y-axis. So let's say the speed is gonna be 0.01, and let's see, refresh, and there you go, it's rotating. So now we got our earth, we got the cloud. So the only thing left is the background, the starry background. Okay, so to add this starry background, what we're gonna do is we're gonna take a really big sphere, and on the back side of this sphere, or you can say that inside of this sphere, we're gonna apply a texture. We're gonna apply this starry texture at the back side or inside of the sphere, and then we're going to rotate the big sphere so it will kind of look like a space. So let's do this. So let's say const star geometry, and let's say new 3 dot again sphere geometry, and this time the radius of this sphere geometry is gonna be 80, right? So obviously we want it really big sphere, and let's say the width segment is 64 and height segment is 64, and then const star material, the material is gonna be, let's say, new 3 dot mesh basic material, so we're going to use a basic material. So why we're going to use basic material is because basic material is a material which does not interact with light. So we don't want to apply light to see our background, right? We don't want that. So that's why we're going to use basic material, that it doesn't interact with light. So let's say basic material and map, and we have to apply this texture, right? The texture is 3 dot image utils load texture, and the path is texture slash galaxy.png, I guess. Let me see, let me double check it. Now we have to create a mesh out of this star geometry and star material. So let's say const dot star mesh equal new 3.mesh, and let's say star geometry and star material, and scene.add star mesh. Okay, now let's hit save and let's see that what it look like. So we can see it, right? We can't see it because it's really big, so it's out of our camera. And one thing is, we have to apply this texture inside this sphere, right? Inside of this sphere. So to do this, let's come to material and let's say side colon 3.backside, 3.backside, and let's say hit save and let's check it out. There you go, our starry background is appeared, but it's not rotating. So if it's not rotating, it's not gonna look so good. So again we have to animate it. So let's go back to our animate function. Let's say star mesh dot rotation dot y. We're going to rotate it on y-axis and again anti-clockwise. The speed is going to be 0.002, slightly faster speed. And now this is save and let's reload it, and there you go, it's rotating. So we got our earth, we got our background, and everything is working perfectly. And now what you can do is you can add some like this menu and this kind of text and the button. To add this, let's say, well, this is optional, you can do it, or if you don't want to, then you don't have to. So let's go back to our index.html to add those kind of thing. Okay, so inside of this HTML file, before this canvas element, let's say div, and let's say class is container, and inside of this we are going to take a nav. So let's say nav and let's give it a class name called, and let's say ul, and let's give it a class called nav menu, and li, let's give it a class called nav items, and let's take a anchor tag and let's say href is this, and let's say home, and there I'm gonna duplicate this multiple times, and let's say about contact and services, and let's say after this nav tag, let's say another div. I'm gonna take another div for the text we have saw. So let's say class title container. Inside of this div, let's say another div. I'm gonna take another div. Let's say class is title, and let's say h1 is gonna be, let me just copy paste this, let's say copy and let's paste it here. Okay, and now let's say a paragraph tag, let's say p tag, and simply I'm just gonna again copy it, paste, format document. Okay, and then we're going to take a button and let's give it a class called btn, and let's say let's clean, and now if I hit save, and let's check it out. Sorry, not this one. Yeah, now it's looking like this. We have to take this on top of this. Okay, now let's go to our style.css file, and inside of this universal selector, let's say padding is 0 and box sizing border box. Well, I'm not gonna take too much of time to deal with this, because this HTML and CSS part, I guess, is fairly simple. You guys can easily understand this. So let's say body. So here I want to remove this is scroll bar. So let's say body overflow hidden, so it will hide that part. Let's refresh. So the scroll bar is gone now. And now let's say container, the whole container, and let's say position is absolute, and let's say top is 0, left is 0, and with 100%, and height let's say 100 vh, 100 viewport. And now if I hit save, now let's refresh it. Yeah, now they are on top of each other. So now let's add some more to our nav menu. Let's say display flex, justify content flex end, to keep it at the right side, and padding let's say 0.5 from top to bottom, and 1 rem or let's say 1.5 rem from left to right. And now it's saved, and let's see, yeah, there we got our menu. And then let's say nav items, and let's say padding of nav item is 0.5 rem from top to bottom and 1 rem from left to right. And then list style is gonna be none, and margin. Okay, now let's say that nav items and the anchor tag. Text decoration is gonna be none, and color is gonna be white. And now let's hit save and refresh it. So before we move further, we need some font to apply those. So let's go to Google font, and I'm gonna choose Poppins. There it is. Okay, so I'm gonna take this one. Let's say I'm gonna take few more. Yeah, I guess that should be enough. And now let's copy this import tag, copy it, and let's paste it on top of everything. Let's copy this, and let's apply this to our anchor tag. And the font width is gonna be font weight is gonna be 200. And let's say hit save, and let's check it out that how it's looking. Yeah, it's looking good. So maybe, yeah, we are done with our menu, and now let's work on this. Okay, so let's say title container, and let's say position is absolute, width is 50%, height let's say auto, and top is let's say 50%. I want to keep it at the center horizontally, and left is let's say 0. And to keep it horizontally centered, let's say transform, translate X. Okay, so now let's set the color for the title. Let's say color RGB. I'm gonna use RGB color. Let's say 231 and 231, 231. And let's say padding from top to bottom is 0 and 2 rem from left to right. And then let's say title h1. Let's say the font family is, let's just copy it from here, Control C, and let's just paste it here. And font width is gonna be 700, and let's style the p tag, title and p. Let's say text align, justify, and similarly the font family and font width is gonna be 400, and color is RGB, and let's say 177. Okay, so now let's say width is 85%, and let's say margin is 1 rem, margin is 1 rem from top to bottom and 0 from left to right. Now let's say save, and let's see, they reload it. Now let's style the btn. Let's btn padding, it's let's say 0.5 rem from top to bottom, 1 rem from left to right. Margin top, let's say 2 rem, and border none. Border radius, let's say border radius, let's say 3 rem, 3 rem, and font family is gonna be this. Font width is gonna be 500, and let's say cursor is gonna be pointer. Let's say background color is gonna be RGB 114 and 255, and color is gonna be white. And let's say it's saved, and let's check it out, refresh. Okay, it's not looking what I wanted. There are some problem. Let's see. Okay, there I have put is translate X, there will be translate to Y, and let's hit save, refresh. Yeah, now it's on the correct position, but the color is, it's not that color which I have chosen. Yeah, the problem is, yeah. Okay guys, so there you go, our landing page is complete and it's looking exactly same. Oh, one second, I did one last mistake, is I didn't add these stacks on this landing page. Oh man, so let's just add it quickly. Let's go to our client.js again. So let's come on top of this animate function, and let's say const is stats equal is stats, and now let's say document dot body dot append child is stats dot dom, and let's add this to our animate function to update it. So let's say stats dot update, and save, and let's check it out, refresh, and finally we are done. Everything is complete, and now obviously you can add CSS Media Query to make your this HTML elements responsive. Yeah, let me check that how much responsive this is. Maybe I forget one more thing. I don't know why I'm forgetting so much thing today. Yeah, I forget to make this responsive. Okay, I forget another thing. Great. So now let's make this background, this starry background and this earth make responsive. Man, I'm forgetting too much thing. So let's get back to our client.js. Just one more last time. Sorry guys, I'm really sorry for this. Okay, let's say window dot add event listener, and let's say we're gonna listen for resize, and the callback function is gonna be, let's say, and we're gonna change the camera aspect according to the resize window, right? So here we're gonna change the camera size or the aspect of the camera according to new window size. So let's say camera dot aspect equal window dot inner width divided by window dot inner height. And now let's update the camera according to new size. Camera dot update projection matrix, and let's say set the new size for our renderer. So renderer dot set size window dot inner width and window dot inner height, and let's call our render function. And let's say here is, let's say false, is false. Okay, and now let's save and let's see, refresh, and now let's check if it's responsive. Yeah, now the background element is responsive, but we have some problem with our HTML elements. Obviously you can use Css Media Query to make them responsive. Okay, so there you go guys. Thank you so much. Thanks for watching this video, and if you have any question or any confusion, comment down below. I'll try my best to answer them. So thank you so much. Take care. Bye bye. Tata.